Alright, so in this equation, or this question, I'm going to find the equation of a parabola with some written information. I'm just going to highlight the written information. It says here the turning point is 2, 6, and it passes through another point of 3, 3. Now we know that turning point form is one of the forms of an equation for a parabola, so I'm just going to write the form here, and then I'm going to substitute the turning point given to us in place of h and k. And I'm going to simplify that and see what it looks like. The 2 is a positive, so it stays as a negative inside the brackets, and the k is positive, so it stays as a positive outside the brackets. Now you might notice we don't know the a value yet, and that's where this second point comes in. So I'm just going to substitute the x and y in place of x and y in the equation to find out what the a value should be. They're both 3, which makes it quite straightforward. Just substitute it in, and then simplify all the way through until you get a equals something. A being, the brackets being 1 makes it quite easy. So this is just going to be a plus 6. Subtract 6 from both sides, and you end up with negative 3 equals a. The final step then is to substitute this a value in place of the a that we didn't know when we substituted the turning point in. So our final answer is always to write the equation of the parabola. Alright, in this question we've been given some information about the x-intercepts and another point. So this clues us into the fact that we're going to use the intercept form of a parabola, which is written like this: x minus x1 bracket x minus x2, where x1 and x2 are the axis intercepts. So we're just going to substitute minus 3 in place of x1 and positive 4 in place of x2. So it's going to look like this. And if you're in doubt as to whether or not this minus sign in the first bracket should change, a really easy way of doing it is just to substitute the actual number in and leave the minus sign in and simplify it later. And you can see pretty clearly that the first bracket has x minus minus 3, which will turn into a positive 3, and x minus 4 in the second bracket. Now you notice again that the a value we don't know, and this is where this second point comes in. So we're going to substitute 1 in place of x and 24 in place of y, and solve down to find out what the a value is. Remember, the 1 goes in place of x in both brackets, and then we can simplify each bracket as we go. That becomes minus 12, divide by minus 12, divide by minus 12, gives you a really nice whole number to work with for what a equals. And the final step is always to substitute what we know for a back into the brackets along with the factors that we already substituted in this step here. Alright, so in this one we're going to have a look at a parabola that passes through 3 distinct points. And so we'll have a look at the points first. Here they are: 1, 4, 0, 5, and minus 1, 10. And you might notice that none of those appear to be any useful information apart from this middle one, which says that when x equals 0, y equals 5. So that is quite clearly the y-intercept. Alright, so that obviously means that the form of equation we need to write is going to be written like this, which is general form, which is the worst one to work with, and the most, or the hardest one in this case as well, because it requires simultaneous equations. So we know the c value is the same as the y-intercept, so we can substitute that in straight away. Ax squared plus bx plus 5. Now, the other 2 points, we have 2 pieces of information we need to know yet. We need to know a, and we need to know b. And when we've been given 2 pieces of information to work with, and we have 2 points, that means we can use simultaneous equations. So we're going to substitute this 1 in place of x and 4 in place of y, and we'll call this equation 1. So we're going to have 4 equals a 1 squared plus b 1 plus 5. Then we'll simplify that for now, so it's going to be a plus b plus 5, and we might leave that there. Now the second piece of information is this third point here, and we're going to do the same thing and substitute minus 1 in place of x and 10 in place of y, and we're going to call this equation 2. So equation 2 will look like this. 10 equals a minus 1 squared plus b minus 1 plus 5. And we'll simplify that here, and we're going to have a minus b plus 5. Alright, now we should remember that with simultaneous equations where there are two methods of solving, we are going to need to simplify equation 1 and equation 2, so we'll just go and do that. We'll move the 5 across to there, so that's going to end up being minus 1 equals a plus b. We'll do the same thing with equation 2. That's going to end up being 5 equals a minus b. Now, we can choose elimination or substitution, and seeing as the equations are already nicely arranged to have an equation 1 has a positive b and equation 2 has a negative b, I'm going to use the elimination method. So I'm going to rewrite them one above each other, a minus b. If I add the two equations, I can see that the two b terms are going to cancel out. Minus 1 plus 5 is 4, a plus a is 2a, and b minus b is 0. So that's going to be 2a equals 4. Divide both sides by 2, end up with 2 equals a. Now the third step is to then substitute this a value back into either of equation 1 or equation 2. It doesn't make a difference, so I'm going to choose equation 2. I'll rewrite it here. 5 equals a minus b. 5 equals 2 minus b. I'll move the 2 across, so that becomes a minus 2. So 5 minus 2 is 3 equals minus b. And then divide by minus 1, and I end up with negative 3 equals b. So I now have an a value of 2, a b value of minus 3, and a c value of 5, which we found out at the initial step. So the final part of this is to then plug those numbers back into the form of the equation that I was using. So then that is general form of the equation using the a value, the b value, and the c value that we found here.